Okay, we've got our final speaker for the session here. We have Dr. Saringi Agata-Moss, who is actually a research staff member here at IDA, woohoo, working primarily in the cyber assessment program. But you recently got some funding to start doing some developing with social engineering and all this data collection standards for CAT assessments, which I'm very excited to hear about. So over to you.
Thank you so much. I traveled all the way from the 8th floor, so I traveled pretty far. But as she said, yeah, I'm going to give you guys an overview of a central research project that IDA funded last year to develop some data standards and an analysis framework for our social engineering and physical ingress work, specifically in our close access team assessments. So the greatest lesson I've ever learned since leaving academia and going into DoD work is get to the punchline. So the punchline is we developed both an analysis reference framework and data standards for our close access team assessments. So this analysis reference framework will categorize social engineering and physical ingress tactics, techniques, and procedures. And it's going to mirror, if you all are familiar, I'm in cyberland, but we use MITRE ATT&CK as a typical framework for on-network red team activity. So this is going to cover more of the social engineering physical ingress work that they do to then garner cyber access. And then we also created data standards for these close access team assessments. And we leveraged the framework and a survey of actual CAT operators to get more insight on what do you do to get in, when you're in there, what do you do, and how do you compromise when you get in there. Like it said, it incorporates information on mission operations received from about 5 of the different CATs that we use actively in our support to the CAP. And it includes data sheets that span the entire span of the mission. So all the way from planning and preparation, more so like when they're already there, all the planning and preparation, all the OSINT that they do, what they do to get in, what they do when they get in, and all of the objective work that they do to enable cyber. So a quick roadmap, I'll give you an overview of how we use CATs right now, and then an overview of the MITRE ATT&CK framework, which, as I said, is the analogous framework for on-network activity. Then I'll give you an overview of some of the development we did to develop the first iteration of this analysis framework. And then I'll give you an overview of the data standards that we created for these close access missions to span all of their activity. So we currently use close access team assessments to enable cyber. So this is when you think about adversary activity on network for most of the work that we do in the cyber assessment program, an adversary is going to get into your network, move laterally, usually escalate their privileges, and then perform some sort of cyber objective. So in that ingress portion, there are multiple ways that they can gain ingress, and one of them is physically enabled. And that's where we perform close access team missions to show how they physically get into a location where networks of interest are housed, and then perform some sort of cyber enabling tactic. So usually that spans from either just touching a system or plugging in a device that either gives you a callback or doesn't give you a callback, depending on the sensitivity of the network itself. So in the program, for that physically enabled piece, the data we currently collect are usually overarching reports, outbriefs after the missions, and we don't really have any sort of analysis framework that groups all of the TTPs that these teams use to move through these locations. Whereas on the on-network side, we are pretty well established in that space. So one of my coworkers actually developed the action, just sort of a pictorial depiction of what's happening on a network, what systems you're in, what servers you're in, what specific network spaces you're in. We have, daily situational reports, and with all of that, we use all of that data in MITRE ATT&CK framework that groups all of these TTPs at these different stages of the attack to then analyze that data and pull out trends that are useful. So what we wanted to do was create a similar basis framework and then also standardize the data we're getting in our CAT missions to do a similar analysis. So our current use of MITRE ATT&CK is I kind of already touched on it a little bit, but we take information on how a non-network red team is navigating. So I give the example here of APT 29, which is a well-known, commercially understood nation-state sort of attack thread to get into a network, escalate privileges, and then perform an objective. And we take information on this sort of attack thread, and we're able to break it down using the MITRE ATT&CK framework, which breaks down TTPs for ingress, lateral, and objectives, to be able to break down how step by step an adversary is able to navigate into, through, and accomplish their goal. So as I said, IDA tends to use we use our data standards, our action maps, our situational reports. We use them with this attack framework that groups these TTPs at each stage to generate attack thread spreadsheets that'll allow us to draw that 1, 2, 3 step-by-step tracking of how an adversary moved through a network. So we really do leverage both standardized data and an attack framework, or a framework that's grouping these TTPs by step of the mission, to be able to generate these attack threads while also being able to pull out trend data specific to those TTPs. So we're able to speak to what TTP are adversaries using to get into your systems all the time? Are they using native tools? Are they using foreign tools? And we're able to pull out that kind of information because of this sort of dual-pronged data analysis process we follow, of having set data standards and an attack and baseline framework for the TTPs. And that's exactly what we wanted to do for close access teams. So that's what we did. And of course, the graduate student in me went back to academic literature. And I wanted to see, of all those smart psychologists out there who have looked at social engineering and how people deceive people to then get into places, piggyback from people, has anybody actually thought about step by step how this is done? And I knew that something was possibly going to be out there, again, because the field within behavioral psychology, there is an entire field of deception, but also a lot of commercial places do sort of physical ingress, close access team work, primarily in their cases to check their physical security. But in this circumstance, we wanted to take that work and see if we could show that physical security sort of mission assessment process and tie it to how we then enable cyber. And so the academic literature we really depended on was very much in the behavioral psychology space, and it did a good job of, again, like kind of clearly going from an ingress sort of lateral movement to objective-ish node for social engineering. It defined the core steps, the flow of a social engineering attack, but it really missed the cyber piece, and it missed it in two ways. It missed it first by the fact that they don't really consider logical ingress as opposed to just physical ingress. So when I say physical ingress, I mean, making a fake badge and getting in, or just piggybacking from somebody. But a lot of the methods that cats tend to use have some sort of logical aspect to it. So even just to make a fake badge, they have to have an RFID scanner and all of that fun stuff. So we wanted to incorporate that piece, as well as, again, the goal of cats, at least how we use them now, is to enable cyber. So their goal is to get into a location to touch a device. So we wanted our objective node, so on the on-network side, is to compromise data, take data. But on the physical ingress side, the goal is to touch or plug in a device to a network of interest. So we wanted to be able to add that in. Another thing this didn't really consider was the compressed timeline of a CAT mission. So this social engineering framework, you'll see in here a little bit, there's steps that talk about like rapport building, what else? Transition, maintenance, like priming the target. And in the examples that they used to build this cycle, they were pretty long term. So it kind of touched on the idea of, okay, I'm gonna call one day, see if I get the secretary. Maybe she's in a good mood, maybe she's not in a good mood. Taking advantage of a lot longer time frame of a mission than we usually have for cats. Cats are usually 2 weeks, 1 week for prep, 1 week for actually aggressing a location. So when we're really trying to break down what happens once they actually get in, we needed something that was more considerable of that shorter timeline. So our first iteration, to try and consider that a bit, I took, looking at all of the CAT data from previous years, I was the main person who analyzed most of the data from previous years. And so I took that knowledge and sort of the TTPs that I noticed that they used to try and update that social engineering cycle that you saw on the previous slide. And we came up with the first iteration of what we're calling the SAR. And here you can see a lot of similarities to what you saw in the social engineering cycle there, but we finally have an addressing of that sort of physical and electronic ingress, but also a better defining of the objective, again, to enable cyber. And I'll point out here that our lateral node is still pretty squishy, and it's at this stage was quite well aligned with the social engineering cycle previously. And so we knew we needed to think about, again, this compressed timeline of CAT missions. And just looking at previous data, because it happened such a long time ago, sometimes because it's not standardized data, you're not getting the same information from each mission. So was there a way for us to improve this framework to consider this shorter timeline, but also get a little bit more structured operational knowledge from our CAT members? So we deployed a survey. And I have Sarah's picture down there because she did a lot of the heavy lifting in designing this survey for our CAT members. And she really took her behavioral psychology background and scoped it in a way that you get the answers that you want without leading people to the answers that you want. And so it was very much designed using intentionally general knowledge, but it was also scoped to touch on each step of a CAT mission. Your planning and prep processes, what you do to get in, what you do once you get in, and what happens when you're actually deploying devices. And so we deployed this survey to about 5 CATs. We got quite a few responses, and we were able to then pull that information. And again, big thank you to Sarah and Amy, who is a summer associate of ours and is actually currently an adjunct research associate of ours, who took all of these responses and started manually grouping those responses based on common terminology under these discrete nodes. Because we know the nodes are correct. We knew they go in, they do stuff when they're inside, and then they deploy a device. But how do they do it? And so she took all of this information, she grouped like terms, and was able to give us a little bit more, something closer to what actually happens during our CAT missions. So you're not going to see much change, at least in this version of the framework, in terms of the ingress and the objective node. Objective node is pretty well defined just based on the program's goals to enable cyber. And the ingress node, at least in my own experience, is pretty well understood even commercially, because if you go out to even like a black hat and they're talking about social engineering, they'll tell you all the fun ways they pick locks. They love to talk about that stuff. So that's pretty well defined, but we were able to confirm that what we knew about the ingress node and the planning and what was happening in the objective node was pretty close to correct. But the most important thing that we were able to get out of this was we were able to finally redefine that lateral node to consider that compressed timeline. So what you'll see here is now we have one tactic under the lateral node, leveraging personal interactions and intermediary access methods in an opportunistic way or in an intentional way. And so you'll see here the entire framework. So we have all of our nodes, all of our mission steps, and the tactics, techniques, and sub-techniques. And that lateral node now starts to encapsulate some of those common terms that you saw from the survey data, some of that piggybacking that they do on the inside, some of the cover story work that they do. But again, it's still pretty loose, but it's our first iteration of finally scoping a framework for actual CAT operations and then specifically to enable cyber. So similarly to what we do on the on-network side, we were able to now take a circumstance, a notional circumstance, all notional data, and be able to categorize it similarly using these tactic techniques and procedures nestled under these specific nodes. So, as you remember, the basis of our data analysis process, at least how we currently do it on the on-network side, that seems to be working pretty well, is we use our standardized data collection sheets, standardized data standards, and an analysis framework that groups TTPs based on where you are in the attack, and take that information and be able to pull out granular trends. And so we wanted to do that for close access teamwork, and the other piece of that was developing data collection standards. So when we started developing these data collection standards, the most important thing to us was for them to be accurate and for them to be easy to fill out, because anyone who has worked with a red team knows that you don't want to put any more stress on them on top of the active mission that they're working. So we developed very simple checklist-based data collection sheets that span all 3 steps of the mission. Your planning and preparation, your daily actions, so that sort of touches on your ingress lateral movement, and then your systems access, which speaks more to that objective node. Something we really wanted to emphasize is that we wanted these to be accurate. Because we're no longer in a circumstance where we have physical action maps that tell me exactly what button you click to move from, well, alludes to what button you clicked to move from system A to system B, a lot of the data we're going to be collecting is who did you interact with? What was that interaction like? Did they suspect you? And so a lot of these data collection sheets were written in a generalistic way to gather some of that information, but we wanted it to be, again, quick enough to fill out that they can complete them by memory. So for our planning and prep sheets, again, the whole goal was for each of these data collection sheets to be directly aligned to a node in the framework. And so our planning and prep really do cover how they gather their information, how they prepare for their mission, and how they formulate their attack. When we first developed these, we initially thought you're only going to fill one out at the beginning of the mission, and then it's just daily activity moving on from there. But what we found actually in some of our pilot work is there's a lot of going back to the drawing board, which isn't surprising, right? Because you don't know who's going to be there on a weekday versus who's going to be there on a weekend. And so it's been nice kind of working with these data collection sheets to see both, am I asking the right questions, but also am I collecting the right amount of data? For our daily actions, these cover activities that would fall under the ingress or lateral node. And these start to speak to, again, those interactions you're having with people, the tools you're using to break into doors, break into offices, all of that, both from a physical and electronic sense. But also, they start to cover this lateral node area of either intentional or opportunistic taking advantage of social interactions. So what we see is in the continued development of both the framework and these data collection standards, we're going to get a lot more fidelity the more data we get, specifically on this lateral node, which isn't surprising because that's where things get the most squishy. And then finally, systems accessed. This data collection sheet is grouped by specific location areas that are known to be common areas for most of our missions. Most of our missions are on military bases. So you have a comm space, you have the commander's office. So we, from the survey, actually garnered a lot of these common areas that they attack, and just common areas from our other combatant command work that we know exist on bases. And we grouped all of the systems that they were able to access and the networks they were able to access based on these regions, because as you can probably imagine, once you're able to pull out this data, you can start to say, maybe you should check if your comms closet is locked because it is it. It seems to be a TTP they use often. So yeah, we're able to directly speak to that objective node from the systems access data collection sheet. So again, we're hoping to mimic the process we use on network by creating these standard data collection sheets, now having a framework with which we can group TTPs based on the stage of the mission, and then create these similar sorts of attack threads where you can quite literally walk with that CAT operator as they got into the location, moved laterally, and performed their objective. And the hope is to be able to similarly pull out trend analysis, like what I was mentioning, TTPs that are common for initial ingress, TTPs that are common for lateral movement. I mean, I think all of us who, work at IDA, but work in any sort of office, know everyone always says, don't piggyback. Make sure somebody scans their badge or anything. And this kind of data would be able to directly pull that information out and tie it directly to successes. So, in summary, we performed a complete and exhaustive academic literature review, and were able to survey CAT members and incorporate all of this information into the first iteration of this framework. And we were also able to create some standardized data collection sheets that sort of directly feed and complement that framework. And what's not mentioned here is This is very much an iterative process. I feel like that's been the theme of DataWorks is iterative continuous improvement processes. And we see this as the first stage and the first pilot for setting up standards for the data, setting up general groupings for TTPs, and using constant data that we're getting to continue to improve that framework. Very similar to how MITRE ATT&CK works now. They have a new version, I think, at least every year. So we're hoping to, again, leverage solid data standards and a framework that groups these TTPs to provide more insightful feedback to the DoD on their physical vulnerabilities, and specifically for us as they relate to cyber vulnerabilities. That's all I've got. Thank you.
Any questions?
Yeah, thank you. Brian Vickers, two things. One is just a clarification on the um, lateral step. All of that was more kind of social exploitation. How do you kind of in practice look at physical explanation, escalation, and getting into the building and then the office and then the room you want to go to? And then the second is kind of how is it working with a summer associate that probably isn't very familiar with this stuff and getting to a useful product?
Yeah. So to answer your first question, a lot of that physical ingress piece is covered in that ingress node. So what I'll actually do, let me get you back there. So that's covered in the physical ingress node, and that covers at least all of the tactics that we know about that they use to physically and electronically ingress. So one of the examples I used before was using fake badges. So the distinguisher here, a physical ingress use of a fake badge would be one that doesn't actually have credentials. So it'd be basically like having your IDA badge, but it doesn't scan anywhere. So in theory, they're taking advantage of the fact that, oh, somebody saw me with an IDA badge, they thought I was great. Let's keep going. The electronic ingress piece of using a fake badge would be if they coded it with actual credentials. Probably not their own, but that's sort of how we touch on that ingress piece, both in the physical and the electronic sense. And then summer associate. So we had a great summer associate. She has a behavioral psychology background, and she is a killer at R. And if there's something that I've learned working this project, specifically with Sarah, because Sarah has a pretty strong test science background, is you guys are very different from us engineers who are like, okay, so what's going on here? Like, what's the essence of what I'm working on? I was a chemical engineer. And so I'm like, okay, what's the polymer? Why does it matter? Then let me generate the data. What I learned from working with Sarah is where and what the problem is doesn't matter nearly as much as what do you want this data to do for you. And so scoping the project around, I want to be able to present a framework. I want to be able to have data standards that then align with this framework and constantly feed back. I was able, and again, with a lot of help from Sarah, to be able to add the context in later because the essence of what we needed the data for was clear.
Hi, Saringi. Lee Allison, IDA. So I have two questions. One, which you may have mentioned and I just missed it. I'm sorry. Have you been using these data collection sheets with actual CAT assessment teams, and what kind of trends are you seeing? Is it been a useful endeavor? Do you have anything that you want to change going forward based on the data that you collected so far? Yeah, any thoughts on those?
Yeah. And I have to be careful of classification here and careful of because this was CRP work, it was primarily IDA, all IDA stuff. The minute we start talking about the stuff that we did for DOT&E, then we get into hairy lands. But majority of you guys, I think, are DOT&E folks. But yes, we have. We've used them with I believe 3 different CAT teams and a total of 5 missions at this point. And at this stage, we haven't compiled all the data to do any sort of trend analysis yet. I could tell you off the top of my head, but again, let's go upstairs. We can talk about that. But some of the lessons learned, at least I have had, is when you deliberately don't put directions on a data collection sheet, that causes people to freak out. So, and we did that on purpose, again, to see how they interpreted each of the questions. And so that was a big one. And I'm like, okay, maybe we should have given them a little bit of something. But also that a lot of the information that we're gathering is not too hard to get from some of the other reporting, but you kind of have to do a little bit of puzzle piecing. And so one of the best parts about these data collection sheets is that we're not taking away some of the other sort of data standards we have programmatically, like I mentioned, outbriefs, any sort of after reporting either by the CAT team or, the DOT&E side. But this will add a level of like granularity that has kind of never existed before. And to me, and maybe this is just me selling it to the cats, but I think it's going to really show some of the level of complexity of the work that we're doing. So to give you some insight on some of the work that Amy's been working on recently, because we actually took her on as an adjunct RA, is she started adding sort of monikers tied to certain TTP combinations. So high and low risk was one that she talked about. And I garnered some feedback from some of the CAT members. I'm like, so which one of these do you think is harder? I could imagine, and I've taken the training before, but which do you think is harder? And so to be able to tie TTP trends to a specific node in the attack, and then be able to add that extra level of, and it was really hard to do, has really been taken the data that we're getting to the next level.